Hey everyone, it's Mr. Sutter coming at you with a quick video on compound interest. So, the purpose of compound interest is to see how things or your money can grow. What doesn't have to be money, it could be population, could be really anything that has some sort of growth based off a certain multiplier. So, we went over in class about simple interest. If I invest $100 and it has a 10% interest rate, after 1 year of that, you're going to get $10, right? So compound interest works a little bit differently. And so I'm hoping to use these tables as a way to teach you how compound simply just means that, hey, we're going to take a sum of money, say, or a pot of money, say $100, and we're going to grow it at some rate, in this case, 5%. And every time period, we're going to go ahead and increase the base and reset the base to a higher amount. So it's kind of cool, and we'll do an activity in class for this too, is that every time, so if I start with $100, for example, I'm going to grow from $100 to 105 at the end of the first period. Okay. And then as we go on and on, you're going to see that the new balance that we're going to start and grow off of is 105, not 100. So, if you're growing off an ever increasing base, that means the amount of continued growth will actually be higher and higher and higher. That's why if you've studied, for sure you guys have studied population growth, maybe in human geography, or just you've seen it somewhere in junior high or even high school. It is an exponential growth in that case, in which you'll see that the more the countries and population grow, the rate of growth may still be the same, but because your base of people, say 1 billion people versus 7 billion people, right, who are having children and whatnot, it'll continue to grow at a faster rate. So it's pretty cool, but unless you're worried about too much of a population in the world. But in terms of money, it's a good thing. So let me explain to you what you're supposed to do here, and I kind of have some of these vocab words to help you. The main thing is typically when we grow money, we talk about in terms of time, and typically that's in years, right? Sometimes you do months, in which case it's a fraction of a year. Um, I kind of messed up on at least terms of time, but just bear with me. So in time zero, I wanted to show, hey, we start with $100 and we're going to end with $105, and you're supposed to show the growth. So the question is, hey, Southard, how do we get that? To find the ending balance, the calculations is very simple. So I'm trying to use what we did in the last class to say, hey, we did $100, right, which is the beginning balance, times that growth rate right here, which is 5%. But in order to do the math with it, we're going to use the 0.05. So I'm going to go and multiply by 0.05. And that's going to equal to, guess what? $5, right? And you'll see right here that I have that $5. Right? That's right there. So that's where that $5 is coming from. That's the growth. And then obviously at the end of this, we're going to go ahead and add that back, right, to the $100 base, which is $105. That's how you get the answer. So that shouldn't be anything like, mind blowing, but there you go. And that's where that 105 is coming from. What I want you to pay attention to is the fact that so we end the year with $105. And the next, I shouldn't say year, but it could be whatever time period we're looking at. Typically, it's years. At the beginning of the next time period, we're going to start with that newer base of $105 instead of 100. What that means is now we've increased our base. Okay. So to do the calculation here, we're going to do the same thing where it's like, hey, we're going to do another not sorry, not $100. This new base of 105 multiplied by the 0.05. So the interest rate never changes, right? And that's going to give me, I think it's $5.25. And then to get the ending balance, you would take the original balance plus the interest, right? So this is no different. This is just the simple interest formula that we've been using. And you're going to add all that together and get 110.25. In terms of the growth, if you want to calculate it, right, it would be the ending balance minus the beginning balance. Or you could just copy and paste what you have here, right, to here. So that's going to be my growth. And let me put that back in black and then red. Okay, so that's kind of my growth. So you're going to keep doing this over and over and over until you get to time period 10. Okay, so that's kind of cool. Let me shrink this up because it looks like I'm using too much space here. just because I want it to fit on one page. So let me go ahead and I'll just delete this guy probably. Whoops. Try and do this quickly. Delete the row. All right, there we go. Now we can actually get to what you notice, what you see. So when you're doing a simple interest calculation at 5% growth, remember, we're doing this for 10 years, right? So what I want you to focus on is, hey, time is 10 years. We have, let's see, our principal was $100, right? Our rate is 0.05. Okay. And then we simply just want to know, hey, what's that calculation look like? For the new calculation, same deal. Time is 10 years. Your principal value is the same, right? Your starting value, and your rate was the same. And if you continue to do the table, right, you'll see in year 10 that the answer is whatever it's going to be. And then whatever that number is, you're going to put, right in here. Okay. So whatever the answer is from 10, you're going to put right in here for the new calculations. Here, let's go ahead and do the math, right? Because this should be pretty simple. Now go ahead and insert, whoopsie, the formula, right? Which is just the interest equals principal times rate times time. Okay, so to do the calculation, let me just insert an equation here just because I can see it better. There we go. So again, remember the formula is I equals P times R times T. And to do that, we're going to go ahead and do, hey, I don't know what the interest is, right? Obviously, yet. We're going to go ahead and calculate it. If I can, if it'll let me. So again, I equals, the principal is $100, right? The rate is 0.05, and the time is simply 10 years. So if we do that math, right, you're going to get an answer of, just throw it in my little calculator. Should just be $50 if I'm not mistaken. Yep, and I'm getting $50 here. So this would give me $50. And then after that, we're gonna go ahead and do the last bit of math, which is, hey, your total is equal to the principal, your starting value plus the interest, right? So that's just going to be $100 plus the 50, which is 150. That's your answer. So you're gonna compare the difference between the two, and you're gonna see like what is the difference. Now you will find that the new calculations growth will be higher. And hopefully you're kind of getting the point that, hey, if I continue to increase my base, right? So every year so what simple interest is doing is you're just stuck with $100. It's like, hey, $100 grew over 10 years at 5%. That's it. Your base is still $100. But in compounding, you'll notice that, my dollar amount at the end of 10 years is actually higher because, right, we keep compounding and compounding and compounding. Uh, so guys, because I started with times 0 and I went ahead and grew it, I kind of messed up there. You don't have to go to year 10. I would just use whatever number you have for year 9 to compare. Otherwise, it's a little bit inflated, which is fine. It'll still make the point I want to make. But you don't have to go to year 10. Why? Again, because I grew it in times 0, which shouldn't have happened. So that's my mistake. Okay. And then you should be able to do the same thing again, in which case, number 3, we're using Elliott, right? We're going to go ahead and grow at 3%, and we're going to compare the difference between the two. So you can see it side by side. And this is for you to see and calculate. Okay. And then we can work on that. So hopefully you're noticing that again, kind of that new interest rate growth, which is the compound interest, is at least in terms of saving money and investing it, will be better off for you. So good luck, and I'll go over this in class when I get back.